Good evening, everyone, and thank you all for being here today. And special thanks to Brenda, Carlos, all of the judges, and all of the MESA directors and coaches as well for taking the time to learn more about what my team has done over the course of this summer. So my team and I present to you Speechsight, the future of lip reading, and Samuel will take it from here.
All right, so to start out with the problem, 1 in 8 people in the United States have hearing loss in both ears. And this has profound implications for both day-to-day life, of course, and interactions with technology. So we set out on a way to kind of ease that interaction between deaf people and other people using technology. I'm gonna bump the slide. And so we started out with our design requirements and the top 3 things that we decided on for our app were that it needed to be reliable. So it has to be able to go from whatever they're looking at, whatever they're hearing into text form easily. It needs to be private because a lot of solutions have middle interpreters per se that are needed to convert from audio to text or video to text, and it needs to be easy to use. So going on to our current market solutions, Live Transcribe is an app on iOS and Android that allows you to record with your phone and it'll automatically convert it to text, but it has some issues that we'll get into later. And Video Relay Service allows someone to call from a dedicated device, which will connect the call to an interpreter who will, in real time, transcribe that feed to someone on a device and then also relay their answers back to the caller. And then I'll give it away to Chris for our solution.
All right, so both of these current market solutions have their own benefits and downsides. So we decided to create a solution, Speechsight, the future of lip reading technology. But what does Speechsight exactly do and how is it different from market solutions? Well, here's a prototype of what Speechsight might look on a user's phone. Speechsight uses lip reading technology to transcribe lip reading into text, which then can be copied onto the user's clipboard or sent to a voice assistant, such as Google Assistant, Siri, or Alexa. Additionally, the users are able to switch between the front-facing and rear-facing camera so they can seamlessly switch between lip reading others or transcribing their own lip reading. So does this actually work? Is this technology real? It sure is. Here's a proof of concept that my team and I have created. Take a few seconds and try to lip read what I'm trying to say on the left side of the screen. It's difficult, isn't it? Here's what the prediction says based on our model. It's a good idea. Here's what I actually said. This is a good idea. The word error rate is 47.8%, and we'll get back to this later. Here's another proof of concept that my team came up with. The prediction said, when it gets tired, I knew it was over. However, I actually said, when I saw it, I knew it was over. This resulted in a word error rate of 50.4%. So was our word error rate of about 50% a huge loss? Not exactly. According to Google DeepMind, a professional lip reader has a word error rate of about 85 to 93%. Our lip reading technology outperforms professional lip readers without having to rely on verbal cues. So how exactly does Speechsight actually work? Speechsight uses something called deep learning to infer the words from lip reading. Deep learning is a technique to perform machine learning and is inspired by the human's brain's own network of neurons. In essence, Speechsight inputs each frame of the lip reading video and data eventually gets outputted as a word or sentence after going through many hidden layers, more than what is shown on this example. So as per the interview phase and inspiration and research, we have created a solution that meets all of the criteria of the deaf and hard to hearing community. By reading the lips of a user, Speechsight ignores all of the background noise. Additionally, Speechsight has a high transcription accuracy when it comes to being compared to professional lip readers. Speechsight is also acceptable to use in public because the user's not talking to their phone, but rather they're mouthing to their phone. Finally, our solution is easy to use because all users have to do is install an app They do not have to talk to an interpreter or anything like that. So here are some comparisons between Speechsight and the current market solutions. Our solution is reliable because it is better than some professional lip readers. It's obviously private because others can't listen on to your conversation. It's easy to use because you just have to install an app and no speaking is required whatsoever. Live transcribe can be reliable, but it is susceptible to background noise and it can't tell the difference between different speakers. However, it is private and easy to use, but requires you to speak. Video relay service or interpreters are reliable, but they are not private because there's a middleman. And it is not easy to use because one has to learn sign language in order to use it. However, no speaking is required. So in essence, our solution meets the 4 key points that we wanted to develop for.
As for how we would implement it, a lot of phones are starting to implement AI chips, which allows them to run lighter neural networks very easily. And it's used in a lot of video processing applications already. So the goal is to develop a lighter model that just crops out kind of your face and mouth so that it can be more easily sent to a cloud service that will run a heavier model with more processing power that will transcribe it into a stream of words. And on to the future. We continue working with the deaf and hard of hearing community. Because that's part of human-centered design, we keep going back and iterating on the problem and the solution. Obviously, improve lip reading model and accuracy. Even though the solution is a lot better than professional lip readers, we think we could take it farther. The next step, integrate with existing platforms. Just our goal is to have it as kind of an alternative input device for alternative to keyboards, and then to grow it even farther, collaborate with tech companies and include it with their apps. And as we go through the human-centered design process even more, we can approach additional problems that we discover. The future of lip reading, even more problems that we could solve. Hands-free phone interaction. Because you can't look at your phone while you're driving, having it look at you and filter out any background noise from your car is a really good application of this technology. Automatic video captioning. Current audio automatic captioning systems have about a 20 to 30% word error rate. And if we could combine it with those systems or even supplant them, we might get better closed captioning. And then lip to speech synthesis for if you really wanted to deepfake that video, you know? All right, any questions?
Does anyone have any questions in the chat? I can't see the chat right now.
I haven't seen anything yet.
Yeah, I haven't seen anything yet. So if any judges have any questions or any mentors or coaches have any questions, please feel free. We have one question from one judge. What were the hard of hearing people you spoke with most excited about?
So I'll answer that one. I believe the hard of hearing people were most excited about the ability to not have to talk through sign language with a translator, and rather they can actually just use their phone whenever they want to communicate to family members or other loved ones.
Great.
I hope that answers your question. Are there any more questions?